I'd like to welcome on stage Philip Krenn. Philip is part of the infrastructure team and a developer advocate at Elastic. Philip, welcome to Athens. Philip comes from?
Vienna.
Vienna. Alrighty, welcome.
Welcome, everybody. It's still early for a Saturday, right? So let's keep this as interactive as possible. So I want to talk a bit about evolution and revolution. And we'll start a bit with the revolution part. Sometimes revolutions happen, sometimes they're violent. We try to not to be violent in IT, but sometimes revolutions happen and stuff changes dramatically. So who knows dbengines.com? It's kind of the Tiobe index for programming languages. This is the same thing for data stores. And they have like a monthly ranking which they bring out to show which are the most popular or widely used data stores. And you can see the relational databases are still kind of on top and leading the way, but MongoDB broke in as the top NoSQL store there. And you can see Elasticsearch has also made it to position 8 right now, which is good. So this is kind of what the revolution was about. Initially, there were only the relational databases there, and now the revolution was that there are not only the relational databases, but also NoSQL stores, whichever flavor they have. By the way, the only system I think that should not be in there is Access. You can see, luckily, I'm very happy that we have finally this month pushed down Access and are in front of Access, because every now and then you see stuff like, I don't know, SQL statement is too complex or query is too complex for Access. Should not be considered a database system. It should not be in that ranking at all. So generally, who is using Elasticsearch, just to get an idea? Okay, that's a good number. Let's see where we can take this. Why am I even talking about that? Thanks for the intro. I work for Elastic. I spend most of my time now at conferences to talk about the good stuff that we do and try and kind of show the new shiny toys that we have. Anybody knows how Elasticsearch got started or was born? It all started, I don't know, in a kitchen is kind of a weird way to put it. But what happened was our CEO, his wife, wanted to become a chef. And she moved to London to take some training and work there as a chef. And what happened was she had a lot of recipes. And she needed something to search her recipes to find out what she could cook with the ingredients that she has ready. And Shai, our now CEO, as a good husband, he said like, well, I might be able to help you out with some technology to build that. And that's what he did. So he started to build some search solution for his wife, which he slightly over-engineered. And she never actually got that recipe search. So she's still waiting for the final application. And she always said, I don't really care that much about what is behind the scenes. I just want to search for stuff. But Shai was always like, no, I want to do this properly for you, and it will scale, and it will do all the right stuff. So that's what he built. And the first iteration was called Compass 1. Then he redid everything, calling it Compass 2. And kind of the third one, instead of calling it Compass 3, he called Elasticsearch. And 3 is probably the lucky number, so that's why this one really stuck. So this was the initial logo. You can see our Photoshop skills have improved since then, because back then Shai was doing everything on his own, basically. And that was kind of the revolution, that he brought out some very scalable, easy-to-use search engine with the REST API that people just wanted to use everywhere. And these are the only terms you need to know for this talk. So, cluster is everything working together to solve your queries is one cluster, which is then made up of independent nodes to answer your queries, and in combination or combined within the cluster, they will answer your queries. Then you have an index that is basically data that belongs together, stored in some unit of thing. That is an index where we put the data. Then we have shards. Every index can be split up into one or more shards, which makes it easy to scale the data and share it across a lot of nodes. You store one JSON document, since, well, JSON is what everybody wants to use nowadays, and every document has an ID. And these are basically all the terms that you need for this talk. So with that, you can see this is what you get when you ping the API or do a get just on Elasticsearch itself. It will say, OK, this is my version number, and it has the tagline, for search. And sometimes we even put that on shirts. So this is still the tagline, and this is the one thing, because we always think a lot of stuff is a search problem. It initially started with full text search, and that is very widely used. So if you use searching on any of these sites behind the search box, Elasticsearch is doing the work for you. And then people figured out they want to do other stuff as well. They want to have some visualization on top of that, and they want to get as much data as possible into that thing. And that's when we added Kibana and Logstash. And together, they formed the famous or infamous ELK stack. And you can see this is what it looks like. Elasticsearch, Logstash, Kibana, and one is sitting on top of the other. And that's the ELK. And then this became very widely used as well. So if you're using Slack, security-wise, everything is going through our stack. Or if you're playing online games from Blizzard, they're monitoring their entire environment with that stack very heavily. So those are some widely used use cases, but we have a lot of others as well. And then we added this one here. This is called Beats, which is like a lightweight agent or shipper that we added to our open source platform. The problem is there is no B, as in Beats, in the ELK stack. So what happened in the end is we started thinking about how could we name this. And then we found out that the ELK is actually an ELK-B personality, and we call it the ELK-B or the BELK. And you can see this is what the ELK-B looks like. So you have the B body and the ELK horns, and this is kind of the combination. And initially, we thought this would be a good thing to use further on. But it turned out we're always about scalability, and this will not scale. Because what happens if we add another product? Then we need to add another letter, we need to find another animal, we need to redo the entire branding and everything, so it won't really scale that well. And then, in the end, we now just call it the Elastic Stack, because that is very scalable. Whatever open source products we have, we can just put them in there, and you can just use them. So that was the revolution. And now we're coming to the evolution. This is kind of like the cool new stuff that we have. And once you have started using the stack, this is what will be most interesting for you, kind of like refining some pain points and some important things. So if you have any questions, by the way, we'll see how much time we'll have at the end. If you have any questions, ask them on Slido. If I don't have time at the end to actually answer, I will just tweet out the answers at the end. But if you have questions, this is the only URL you need to remember, sly.do/Xera. Just post your questions there, and I will answer afterwards. So this is the one to remember for any questions. Everybody has that? Cool, then let's jump into the meat of this. So generally, I always say this is about growing up. Because you start something that is easy to use, but as soon as you have more production users, you figure out it's very important to be very stable and mature. And sometimes then you need to change things that you thought initially were a good idea, because it was easy to get started, but it's sometimes not that good for production use cases. So for example, one of them is strictness. What we added, or what we are trying to avoid, is doing bad stuff. Because initially, when you were doing something stupid, we were just trying to ignore that and say, like, whatever you're doing, we'll just try to interpret it as, well, the right way. We'll just try to guess what to do. But now we're trying to avoid that bad stuff altogether. So we have, for example, added these bootstrap checks. Has anybody run into the bootstrap checks? Nobody. Good. Because sometimes people complain about those. Those are basically settings where we know this will not work in production in the long run, and you will have a bad time later on. So instead of starting up and letting you run and then hit the wall later on, we will actually stop the node when it's starting up. And we will tell you in an error message like, hey, you're doing something that will probably either corrupt your data or will take your cluster offline later on. So for example, if we see you have very few file handles configured, in production, you probably want to have enough file handles. We actually have a development mode and the production mode. And basically, as soon as you can form a cluster over more than one node, we assume you're in production mode. And then we will enforce these checks. And people are always asking, like, can we kind of disable that and say we don't care about that? But we explicitly did not add that, because then everybody would always say, yes, we're in development mode, don't bother me. I just want to have this working now. And we're not trying to do that. So just to give you a quick idea, I have my cluster running in the background, so you can actually query that. My cluster should have 3 nodes. There should be Elasticsearch 1, 2, and 3, but Elasticsearch 2 is badly configured, so it never really came up. So for example, if I check, I'm using Docker because everybody has to use Docker nowadays. like the important part here is in Elasticsearch 2, we're basically saying this is bound to a non-loopback interface, so it could form a cluster. So we assume you're in production mode. And then it actually figures out the bootstrap check here failed, and then it's actually taking down the node. And you can see here, my node actually exited with an error code because the bootstrap check failed. And we'll tell you very hard that this is what is broken. In development mode, if you're just binding to localhost, we would just give you a warning. In production, we'll actually fail your node. So let's take this down and let's fix it. So what I've done, basically, I have done a very bad memory setting here, which you should not do. We'll fix the memory setting. And then once my cluster has come down, come on. Die cluster. Very good. We have killed it as well. Now we can start it up again and it will work. Just to give you a quick idea, while this is starting up in the background, what we're doing is we have Elasticsearch 1, 2, and 3. It's just a 3-node cluster that we have running with a specific Elasticsearch version. We will come to that later on. I have configured some things. So for example, my instance has 1 gig of memory and half a gig of heap. That's generally always half of the memory should go to the heap and the rest is just file system level caching. We map or bind mount the directory where we store the data, and then we are doing the same thing for Elasticsearch 2, 3, and then we have 1 Kibana instance, and the 1 Kibana instance is there just to interact with it. And you can see this is talking to my Elasticsearch 1 node. And just to avoid any confusion later on, I'm binding the Elasticsearch host or port to 9201 for Elasticsearch 1. Elasticsearch 2 will bind to 9202, and Elasticsearch 3 to 9203. So this is just the setup that we have. And while I've been talking, in the background you can see my Elasticsearch nodes and Kibana is coming up. And it will hopefully take just a few more seconds until this is working again. So let's see if I refresh that, if everything is working again already. Yes, very good. So let's check, do we have all 3 nodes already? Yes. Now we have all 3 nodes, we have fixed our setup, and stuff doesn't break anymore. The other thing that we have, for example, changed is around strictness. What we previously did is, if we did not know a parameter, we would silently ignore it, which would make debugging extremely hard. Can anybody see the typo in this query? So there is there's an E missing here, and that's probably very easy to miss, because what happens in previous versions, we would silently ignore that entire parameter. What we do now, if you run that, it will actually tell you, okay, something is wrong, I don't know that parameter, search tip is unrecognized, but if you maybe you meant search type instead. And this is built on the Levenstein distance, so it knows, okay, there is something very similar to that, maybe you want to use this. You can see the same thing if you use git on the command line and you mistype, it will also say like, hey, there is this very similar command, maybe you mean this. And this is actually what this one means here. So if we add the E and then run the query, then it finally works. Previously, both in the configuration file and in parameters, we would otherwise just silently ignore it, which was, even for us, very hard to debug normally and not a lot of fun. Okay, so those are these checks. The next thing we have added, maybe if you've been on an older version, upgrades were often very painful because you had to take down the entire cluster to do a major version upgrade, upgrade all the nodes, and then bring up the cluster. And while you were doing that, nobody could query anything. So that was kind of a pain point. What we've added now is we want to allow you to keep running while upgrading the cluster, and it will look something like this. And you always hope that your train is not derailing while you lay down the tracks. And we'll actually try that out now as well. So what we're doing here is we'll need these 3 documents for one of my demos later on, so let's simply insert them. We'll come back to them in a moment. So we've inserted those. The first thing you want to do is you want to run an upgrade check. So we have added a new upgrade assistant to actually tell you something is maybe bad in your cluster. And then you have here this cluster checkup, which will tell you, okay, there is one error. And it will actually tell you what you need to do. You could now manually fix that, but we even have a helper to do that for you. And by the way, before you start this in production, please take a backup or a snapshot before. Since this is a demo, I'm skipping the snapshot, but please, please, in production, do that. Otherwise, we don't take any responsibility for that. So what we're basically doing here is, we know there is some format that needs to be changed in the background. We are doing that. We have replaced that old bad index with a new version. If I run my check again, you can see, okay, there is a note, but not even a warning anymore. So now we can actually upgrade my cluster. Nope, that's not the window I need. Let's stay here. So what we need to do is, so while our setup is running, I'm basically switching my version from 5.6 to 6.2.4, which is the latest version. And basically, I kill my Elasticsearch 3 node and replace it with a new version of the new major version. In previous versions, this would not have been possible. You could only have a cluster within one major version. But what this should do is that it will, you can probably see it here, that there is an Elasticsearch somewhere at the very end here. You can see we're killing, or we have killed Elasticsearch 3 here, so that node has exited, and now you can see new container, new color. So before it was like yellowish, now it's reddish. My node is coming up, and it will join my cluster in a few moments again. And while this is running, you can check. Okay, that was quick enough, so you can see now we have the major version here already. I'll quickly replace the next node and then explain or show a few more things. So basically, we're killing the number 2 node, and that will fall over, and then the other two will keep working. So if you run that, you can see now my Elasticsearch 2 node is gone. You can still keep reading and writing data while this is in progress. So no more downtime deployments. This will just replace nodes on the fly, basically. And you can always ping and see how soon does that node come up again. And depending on how impatient you are, you can actually check then here, okay, my Elasticsearch node 2 has just started again. Now it will join the cluster. So probably it is back up again. It is back up again. So we can already keep heading over to the final node. This will take down Elasticsearch 1 and do the same thing. And now Kibana fails. Why does Kibana fail? Yes, because Kibana can only take to a single Elasticsearch node. And I've quickly shown that in the Docker Compose file. This is the Elasticsearch 1 node it is trying to talk to. So while we cannot use Kibana now, we can fall back to the command line. So for example, I'm curling the number 2 node. You can see the number 2, that is what I'm using here. If you run that, okay. And I was talking too much because it has come up already again. So now we can refresh Kibana. Kibana is coming up again. That has worked. The only thing that we still need to do is replace Kibana itself. So let's quickly do that as well, because you can see this. That will get a little prettier or funnier or nicer. So anybody who complains about Java applications taking a long time to start up, wait until this node application comes up. Because the Elasticsearch processes were starting up moderately quickly, but Kibana, this will now take at least half a minute until, well, it's died, and then it's coming up again, and it's found. So this is the one process that will probably take the longest in our process. But it doesn't really matter because, well, your applications can keep querying the cluster, and nothing bad is... no, that's not what I wanted, sorry. I wanted to keep querying that, so okay. It will start over, it will kill Kibana again and start over. But there's probably nothing to change here anyway, because no version changed, so this will just keep running, and yeah, you can see. Come on, node application, come up. I will skip a little dance on stage. I hope it just comes up. Let's see. Yeah. As I said, that one can take some while. But status changed from red to green. That looks good, so it should be up again. Hopefully. You can see the logo is now slightly different, and the color scheme also changed. I always say version 3 was black, 4 was white, 5 colorful, and 6 blue. Why did we change from colorful to blue? Because if you're colorblind, this is said to be much more readable. So this should be nicer on the eyes. So now you can see my node I'm connected to is 6.2.4. That works all as expected, and I have back my cluster. So live migrating a cluster on stage, it's always scary, but it generally works. And if it works on stage, it probably works in production for you as well. So, next up, a bit more about securing your data or making sure nothing bad happens. One of them is, if there is a lot of flooding, bad stuff might happen. And it might look something like this, that you kind of fall over unexpectedly at some point. And we want to avoid that. So what we had in previous versions, we had the low and the high watermark. The low watermark basically means don't allocate a new shard on this node if you have used more than 85% of the disk space on that node. If you have used more than 90% of the disk space, actively try to migrate shards away. In 5, we've added a flood stage watermark. And in 6, we've added the flood stage watermark. What the flood stage watermark is doing, basically, if you're trying to write data to a node with more than 95% of the disk used, it will actively reject the write operation. So we won't keep writing data and maybe lose a write or corrupt your entire data set. We will actively reject your write operations to do that. So what that looks like is I'm creating a new index, which I called my flood, with one document that works well. And then we can check out how much disk do I have available on my node. You can see I have this Elasticsearch instance has 31 gigs of memory free in total, but available are only like 25 gigs. And what I'm doing here is I'm basically setting the low watermark to 100 gigs, a high to 50, and flood stage 30. So I will hit all of those flood stages now immediately. And this will be updated after 10 seconds at the latest. So this is what this entire section looks like. So after 10 seconds or so, this will be updated. Can I still read something from that index? Yes, reading should always work. Can I do an update or a write? No. Could I just do an update of an existing document? No, because since we are an immutable data store, it will only always write a new document and then replace the old one or get rid of the old one. So when I do that write operation, it will actually tell me, okay, this operation was blocked now because, well, the index is in read only and it only allows reads or deletes. And so my index is blocked again. So what I'm doing here is I will reset those values now to the default values. So for example, this was added in 5. If you wanted to not set an explicit value but fall back to the defaults, you would just set values to null. And, well, that has been accepted. Will my write operation work now? Who thinks yes? Who thinks no? You should be more pessimistic. So this will not work because it will still tell me that my index is blocked. Why? Once an index has been blocked, you need to manually release that. We might change it in the future that if we see if you fall low enough on disk usage again, we might unlock it. What we want to avoid is that it's basically toggling between two states. So if you're kind of on the edge of 95% and some write operations succeed and some fail, that would be kind of a very weird state and you don't want your cluster to be in that. So what you basically need to do is you need to reset for every single locked index. So if you try to write to an index where a single shard is on a node with too much disk space, it will lock the entire index. And then you will need to release that index again. So here I'm releasing my flood stage. I'm setting that read only or delete to null. And then you can happily write to that again. So that will work. You just need to not forget to actually release that again. Okay. Next thing we have added are sequence numbers, because sometimes keeping track of things is very hard. And sometimes your fingers are not enough to keep counting your documents. So what we have done is, assume we have a primary and 2 replica shards. We are writing to the primary, it automatically replicates my document 0 to the replica shards. And then it has a local checkpoint where it sees, okay, I'm in sync with the primary shard, and a global checkpoint where the primary shard says, okay, I've seen the acknowledgements from all the replica shards. And I know that everybody has received those write operations and has basically applied and done those correctly. If something is not in sync, we know since we're missing 2, we cannot move the local checkpoint any further, but once we have everything, we can move the checkpoints again. Now what will happen is we're trying to do 3 write operations. One of them will go, or some will go to some node and then the other node. Now my primary shard is failing, and the new primary shard is the middle one. and it has never seen that for write operation. So what it basically does is it tells the other replica to roll back the document for, because it should not have seen that. It cannot go to the other shard and say like, hey, maybe you have seen those. It will just, whoever is the primary shard will decide on what is the current state, and it will make sure that all the other shards, or sorry, replicas, all the other replicas have the same data state. And this would have been very hard in previous versions. And you can actually show that as well. Oops, that's not what I wanted. This one here. So I'm creating an index sequence numbers with one primary shard and one replica shard. And I explicitly tell it not to write its data to Elasticsearch 1. Why are we not writing to Elasticsearch 1 in this example? Any guesses? Because Kibana is talking to that, and I need to kill nodes, and I don't want to go or Kibana lose the connection again. We have created the index, and now if you show that, you can see the primary shard here is on Elasticsearch 3, and the replica shard is Elasticsearch 2. Everybody remember that the primary shard is Elasticsearch 3 because we will need that in a few moments. And you can keep writing to that one. This part here is what you've always seen before. This one here is new now. So basically what we do is we keep track of the write operation. So every write operation I do, the sequence number will increase. The primary term always only changes if I change the primary shard. You need both of them to keep track of who has received what writes and what is your current data state. If I write to one specific document, it will still keep counting up. If I delete that, will it count as a write operation? Yes. Every change is a write operation. So now I have deleted my document. What if I do another delete? It doesn't change anything. Will the sequence number go up or will it stay the same? It will still go up because even though it doesn't change anything, it's still kind of an operation I try to run on my cluster. So what we want to do now is we want to take down the primary shard, which means we need to take down which node? 3. So we are stopping Elasticsearch 3. Hopefully that has worked. So you should see, okay, it has exited. If we check what is going on here, you can basically see, even though that's a little hard to read, you can see now the primary shard is on Elasticsearch 2, and the replica shard is unassigned. Why is the replica shard unassigned? Because there is no rule basically where you could put that. We will never assign a replica shard on the same node as the primary or any other node because, well, it doesn't help. If the node goes down, the data is gone as well. Elasticsearch 3 is down, and I've said this index cannot put its data on the Elasticsearch 1 node. So that's why the primary shard is now unassigned here. You can keep adding documents now, and in the meantime, we can also restart. Oops. We can restart my 3 node because we will need that one. In the meantime, we can keep writing, and at some point, my 3rd node will come up again. So, and then you will also see once the node has come up again, it will be able to actually replicate the data again. And well, let's see what it's doing. Okay, yeah, initialize, starting, so it should just join the cluster again. Let's see. And now you can see it has come back. It's the new replica shard, so you can see primary and replica. Elasticsearch 3 is now the new replica shard. So it has kept kind of the primary shard is staying the same. What is kind of the new magic in that is that we were able to recover the documents that were written in between from the so-called transaction log. So you can see there is this 13. I've done 13 write operations while Elasticsearch 3 was down. And I've basically replicated from Elasticsearch 2 to 3. I've replicated 3 documents because I have all the documents just written out in a transaction log. In previous versions, we would need to go down to the disk and copy the segments. And those might have been slightly different on different nodes. So we might have had to transfer a few gigabytes of data just because we missed 13 write operations. So this should make recoveries much smoother. And then there's always the question, what if we run out of sequence numbers? That is, especially if you're using Postgres, they have like a global transaction ID, which is an integer. And if that runs out, and you don't run an auto vacuum frequently enough, and you run out of IDs there, you will not be able to do any write operations. Do we have a similar system in Elasticsearch? No, we don't, because we don't use an int, we use a long. And the other thing is the long is on a per shard level. And that is actually also very easy to show. So if I delete my sequence numbers and instead I create 10 shards now. So I have 10 primary and 10 replica shards, which you can see here, 10 primary, 10 replica shards. And now when I write documents to that, you can see sometimes the sequence number is 0, sometimes it's 1, sometimes it will be 2, but this is pretty much accidental on whichever shard we are writing, and that is a counter per shard. If I use one document ID, it will always go to the same shard, and then it will be nicely incrementing, but this is on a per shard level. So we don't have any fallback strategy for that. You will probably never run out of sequence numbers. I think I've done the calculation. If you do 1 million write operations per second to a shard, it will still take like 300 years or so until you run out of them. So we don't have a fallback strategy for that, but probably you don't need that. The trade-off is, per shard, you will need extra disk space. And these are the default settings. By default, we will keep up to ½ a gig of write operations or up to 12 hours of write operations. So you will need to keep a bit more track of the disk space you're using, because that is on a per shard level, depending on how busy your shards are. Probably the 12 hours will kick in first, and you will only write a few megabytes or 100 megabytes, but you might use the full ½ gigabyte per shard. And this feature, by the way, will also enable other cool stuff, like probably cross-data center replication or cross-cluster replication, where we'll basically take the data and replicate it to another potentially remote cluster. Because now we have this transaction log, and we can just take all the write operations and ship them off asynchronously to another cluster. This is probably the one change that will hit everybody the hardest, is that types are going away. Who is aware that types are going away? So why are we doing that? Because types were always a bit of a lie. And sometimes you need to drop the lies and try to kind of like be honest. Or what were the problems? So Lucene, which is writing the data in the background, never had the concept of types. And if you had multiple types, the fields always had to use the same data types because they were basically mapped down to the same field. So if you have two types in an index and you have like a field called deleted, and you would think in one type I want to make that a Boolean because I deleted a user, and the other, or disabled, and you set the disabled flag, and in another type you want to have the disabled field a timestamp for when you actually disabled the user. This would not work because it needs to map down to the same data type. Also, probably you have more sparse data because you have more fields and not all of them are filled, which would cost a little more disk space. That was improved in the Lucene 7, which is also part of Elasticsearch 6. This was improved, but it's still a bit of an issue. And scoring is always across types. And that would sometimes throw you off for search quality. So what we're doing is, this is a very multi-year thing we're doing. So you could opt into having a single type per index in 5.6 optionally. In 6, this is the default. You can disable that, but you really should not, because the pain will come back to you afterwards. In 7, you cannot have multiple types in an index anymore, and the types in the API will be optional. And you can use both types and no types in 7, so you don't have any breaking changes anywhere. You can change that within the version. And in 8, finally, all the types are gone. So, just to quickly demonstrate that. What you have is, let's just say I want to create a new index called types. And then I create an index with the type _doc, which is the new recommended value. You can use any value, but you can only use a single one anymore. So I'm using that one, and then I try to insert another document with the type other. What will happen? My write will fail, because obviously I have multiple types, and it will tell me you can only have one. I still have imported the data with the multiple types from 5. That is still possible. If you import data from an older version, you can have multiple types. But you need to migrate that data to avoid the pain later on. So what I'm doing here is I'm saying _reindex. Basically, I'm taking my data from the types index and migrate it to the no types index. And then I actually concatenate that with the values that we have, because types _search Here you can see we have types, and they have the type 1, type 2, and type 3. And all of those documents have the ID 1, because you could have one ID per type. So what we're doing here basically is we're saying the new ID is the concatenation of the type and the ID of the document. So it will be type 1-1 or type 2-1. The new type, instead of using the underscore type field, we'll just use type. This is a custom field, but you can totally do that. And the new type we'll just set to underscore doc. And when you let that run, you can see we have migrated 3 documents in total. And if you search those now, you can see we have 4 documents. The one that we created initially, the underscore doc with ID 1. And then these are the migrated documents. And this is the strategy to get rid of multiple types per index and run that upgrade strategy here. OK. We have 2 kind of cool optimizations added. One is automatic queue resizing. So basically, you want to say, my search queries should respond within 2 seconds at most. And rather than queue them up if you have a lot of queries longer than that, we will actively reject them. So what you can say is, I want my queries to respond within 2 seconds. We will figure out, currently you're serving 50 requests per second, and that will give you a queue size of 100. And once you have queued up 100 elements and you want to add another search to a queue, we will actively reject your search operation, and then your client needs to figure out, what do I want to do? Do I want to retry, and it might take longer? Or do I need to take some other step there? The other thing is adaptive replica selection. Previously, we have been taking a random primary or replica shard to search your data. Now we are trying to figure out which is the least busy node. For example, if you have a garbage collection on one node, we might not go to that node, but we'll go to another node. There's a nice paper on that, how to do that. And basically, we are figuring out which are your least busy nodes, and we will always try to use the least busy node for queries. We did some performance checks. It should give you a nice boost, especially if you have multiple copies and a busy cluster. It should improve, especially something like the 99th percentile should improve dramatically. The final demo I have is shrink and split. So these were things that people have been asking for a long time. So I'm creating a new index. How many shards will that have with the default settings? 5 shards is the default setting. So 5 primary shards is what we will get. So if I check that out, you can see, OK, 5 primary shards and 5 replica shards, which is probably hard to tell here, but this is what you get. And then what I do is I want to shrink that down to a single shard, because I don't need that many shards here, because I don't need to scale up that much. I only have 3 nodes anyway. Basically, what I do is I tell my shards that one copy, primary or replica, needs to be on Elasticsearch 3. So I can then hard link those together and actually combine them easily. So what I'm doing here is, on the shrink index, I call the API endpoint underscore shrink and store the result in the shrunk index with 1 shard. And that's basically just hard linking the segments together, or the shards. And then you can see now we have 1 primary and 1 replica shard. So that way you can easily shrink down the number of shards. This here, the number of shards basically always needs to be a factor. So we are always combining shards together. We cannot split them in any other way, which is not that great if you have a primary number as the default number of primary shards, because the only place where you can go from 5 is 1, unfortunately. We can also go the other way around. You can also split. So you can basically say, I want to have 1 shard now, but I want to be able to split into any factor of up to 20 later on. And this is my split index. So you can insert a document in your split index. You can see right now we have 1 primary and 1 replica shard. You basically need to tell it, I want to block write operations right now, and then I want to split my index. So I take the split index, call the underscore split API on it, and then store it in split in 5. That is my new index. And that is, well, 5 shards, because 5 is a factor of 20. And then you can see, OK, suddenly now we have all these shards, and you still have all your documents there. And we've broken those up into more shards, which you can then easily spread out over more nodes. So yeah, this is pretty much what combining looks like. You try to put stuff together and hope that it works out and doesn't end up in a weird state. And you can also shrink. So that was the shrink. And you can also split. And split pretty much looks like this. that you break up your data in a more or less violent fashion. And right now you need to define that way of how you can split that up, but in 7 we'll get rid of that limitation and you can split up in any possible combination then to make it scale up more. We already said that 5 is kind of a stupid number for a number of primary shards. This has been a year-long or like multi-year-long discussion internally, and we have picked the new default for the number of primary shards. Any guesses what would be a better number for the number of primary shards to have? 3. But 3 is also a primary number. There is no real good solution. In 7, we'll actually change the default to 1. Because you can split it up later on if you need it, and to get started, often 1 would be the best choice. Because you don't need the overhead of more shards than that. So 1 will be the new default in 7. Yeah. What we're also always doing is benchmarking. The one thing that a lot of companies do when they benchmark with competitors is something like this. They find some scenario where they are kind of better than the others, and then they will say, oh, our system is so much better than all the competitors. And I've seen that, I think MongoDB, Cassandra, and Couchbase, each one of them did a benchmark with their competitors, and everybody found some scenario where they were at least twice as fast as the others, and everybody did that. So this is what you get when some vendor benchmarks against their competitors. So I would never trust those benchmarks, and you will always need to find your own scenario in benchmarks. We only benchmark very strictly internally to avoid the slow boiling frog problem. Anybody aware of the slow boiling frog? So if you throw the frog into the boiling water, it will figure out something is wrong, and it will try to jump out immediately. If you put the frog into the cold water and then slowly heat it up, it will sit in there and be very happy and die. Maybe, I'm not sure about the happy death, but it will die a certain death. And we're trying to avoid that by always benchmarking. So we have nightly benchmarks to avoid that, oh, you do one change, everything gets slightly slower, and another change and everything gets slightly slower again. So we don't want to be the frog that gets slightly boiled to a slow system. We want to avoid that. So we have benchmarks of that. We are trying very hard to not run into that problem. So to wrap up, these are all the things that we've seen and discussed today. And just one side note, if you haven't heard enough about Elasticsearch and our stack, we're organizing a meetup on Monday at 7 in the Cube, which you probably know better than I where that is, but this is where we are doing a meetup on Monday, if you want to hear more. And with that, I think we're pretty much out of questions. Before I go away, I always take a picture with you so I can prove that I've been working. Smile, everybody. Smile here as well. Do we have time for one question, or are we out of time? We have some time. Awesome. Then, are there any
2 minutes,
questions?
yes. Questions, guys? There we go.
By the way, while you're running, who is still on an older or version 2 or older? Just to get an idea. Who is on 5? Who is on 6? Okay, it's moving in the right direction.
Hi. I don't completely understand what a shard is, although I've been using the Elastic Stack for quite some time. But I have a very specific question. When do you need more shards, and when do you need less shards?
So the question is, when do you need more shards, and when do you need less shards? So, what is the problem with shards? Because initially you might assume more is better. And some people tried that and said like, oh, I create an index and I will use 100 shards because more is better. But there is a certain overhead for shards. So you will need file handles and memory for every single shard. And also, if you have 100 shards and you search, you will need to combine 100 little results together. So there is a certain overhead. Why do you want more shards? So you can use more servers. Especially if you are write heavy, you want to spread out the writes through all the servers, through primary and replica shards, and then you want to have more shards. So if you have one shard and 20 nodes, you will not be able to scale very well. So that is a trade-off, and you need to find the right combination of how much data do I have and how many operations, and what is the overhead of that. What you should not have is more than a few, so if you have 100 shards or more per node, it's probably taking more overhead than it's worth it. That is kind of, and your shards should generally have a size like 10 to 50 gigs of data. It will depend a bit on the use case, but it should at least be multiple gigabytes per shard of data what you have. If you only have megabytes per shard, you're doing it wrong. And you will feel the pain at some point.
Before I take another question, is Christina Alden in the room? No? Okay. Any more questions? Don't be afraid to raise your hand.
Otherwise, come to me afterwards if you have any.
Otherwise,
And I will post, if there are any questions on Slido, I didn't check yet, I will tweet them out afterwards.
so are you hanging around for the meetup on Monday?
I will.
Fantastic. So we'll see you at the Cube on Monday then, with you and I hope as many Elastic users
Yes.
as possible. Awesome. Thank
And
you
we still
very-
have a few stickers up here, so if you're quick, you can grab a sticker as well.
All right, guys. Thank you
Thank
very
you.
much, Philip. Thank you. Thank you.